Atom bomb is the most destructive weapon in modern era. Almost every country wants it. Let's check some facts about it. Atom bomb, weapon with great explosive power that results from the sudden release of energy upon the splitting, or fission, of the nuclei of a heavy element such as plutonium or uranium. When a neutron strikes the nucleus of an atom of the isotopes uranium-235 or plutonium-239, it causes the nucleus to split into two fragments, each of which is a nucleus with about half the protons and neutrons of the original nucleus. In the process of splitting, a great amount of thermal energy, as well as gamma rays and two or more neutrons, is released. Under certain conditions, the escaping neutrons strike and thus fission more of the surrounding uranium nuclei, which then emit more neutrons that split still more nuclei. This series of rapidly multiplying fissions culminates in a chain reaction in which nearly all the fissionable material is consumed, in the process generating the explosion of what is known as an atomic bomb. Many isotopes of uranium can undergo fission, but uranium-235, which is found naturally at a ratio of about 1 part per every 139 parts of the isotope uranium-238, undergoes fission more readily and emits more neutrons per fission than other such isotopes. Plutonium-239 has these same qualities. These are the primary fissionable materials used in atomic bombs. A small amount of uranium-235, say 1 pound, cannot undergo a chain reaction and is thus termed a subcritical mass. This is because, on average, the neutrons released by a fission are likely to leave the assembly without striking another nucleus and causing it to fission. If more uranium-235 is added to the assemblage, the chances that one of the released neutrons will cause another fission are increased, since the escaping neutrons must traverse more uranium nuclei and the chances are greater that one of them will bump into another nucleus and split it. At the point at which one of the neutrons produced by a fission will on average create another fission, critical mass has been achieved, and a chain reaction and thus an atomic explosion will result. In practice, an assembly of fissionable material must be brought from a subcritical to a critical state extremely suddenly. One way this can be done is to bring two subcritical masses together, at which point their combined mass becomes a critical one. This can be practically achieved by using high explosives to shoot two subcritical slugs of fissionable material together in a hollow tube. A second method used is that of implosion, in which a core of fissionable material is suddenly compressed into a smaller size and thus a greater density. Because it is denser, the nuclei are more tightly packed and the chances of an emitted neutron striking a nucleus are increased. The core of an implosion-type atomic bomb consists of a sphere or a series of concentric shells of fissionable material surrounded by a jacket of high explosives, which, being simultaneously detonated, implode the fissionable material under enormous pressures into a denser mass that immediately achieves criticality. An important aid in achieving criticality is the use of a tamper. This is a jacket of beryllium oxide or some other substance surrounding the fissionable material and reflecting some of the escaping neutrons back into the fissionable material, where they can thus cause more fissions. In addition, boosted fission devices incorporate such fissionable materials as deuterium or tritium into the fission core. The fissionable material boosts the fission explosion by supplying a superabundance of neutrons. Fission releases an enormous amount of energy relative to the material involved. When completely fissioned, 1 kilogram, 2.2 pounds, of uranium-235 releases the energy equivalently produced by 17,000 tons, or 17 kilotons, of TNT. The detonation of an atomic bomb releases enormous amounts of thermal energy, or heat, achieving temperatures of several million degrees in the exploding bomb itself. This thermal energy creates a large fireball, the heat of which can ignite ground fires that can incinerate an entire small city. Convection currents created by the explosion suck dust and other ground materials up into the fireball, creating the characteristic mushroom-shaped cloud of an atomic explosion. The detonation also immediately produces a strong shock wave that propagates outward from the blast to distances of several miles, gradually losing its force along the way. Such a blast wave can destroy buildings for several miles from the location of the burst. Large quantities of neutrons and gamma rays are also emitted. This lethal radiation decreases rapidly over 1.5 to 3 kilometers, 1 to 2 miles, from the burst. Materials vaporized in the fireball condense to fine particles, and this radioactive debris, referred to as fallout, is carried by the winds in the troposphere or stratosphere. The radioactive contaminants include such long-lived radioisotopes as strontium-90 and plutonium-239. Even limited exposure to the fallout in the first few weeks after the explosion may be lethal, and any exposure increases the risk of developing cancer. The first atomic bomb was built in Los Alamos, New Mexico, during World War II under a program called the Manhattan Project. Los Alamos was approved as the site for the main atomic bomb scientific laboratory on November 25, 1942, by Brig General Leslie R. Groves and physicist J. Robert Oppenheimer, and was given the codename Project Y. One bomb, using plutonium, was successfully tested on July 16, 1945, at a site 193 kilometers, 120 miles south of Albuquerque, New Mexico. The first atomic bomb to be used in warfare used uranium. It was dropped by the United States on Hiroshima, Japan, on August 6, 1945. The explosion, which had the force of more than 15,000 tons of TNT, instantly and completely devastated 11.4 square kilometers, 4.4 square miles, of the heart of this city of 343,000 inhabitants. Of this number, some 70,000 were killed immediately, and by the end of the year the death toll had surpassed 100,000. More than 67% of the city's structures were destroyed or damaged. The next atomic bomb to be exploded was of the plutonium type. It was dropped on Nagasaki on August 9, 1945, producing a blast equal to 21,000 tons of TNT. The terrain and smaller size of Nagasaki reduced destruction of life and property, but 39,000 persons were killed and 25,000 injured. About 40% of the city's structures were destroyed or seriously damaged. The Japanese initiated surrender negotiations the next day. After the war, the United States conducted test explosions of atomic bombs in the Pacific Proving Grounds in the Marshall Islands and in Nevada. In subsequent years, the Soviet Union in 1949, Great Britain in 1952, France in 1960, China in 1964, India in 1974, Pakistan in 1998, and North Korea in 2006 tested fission weapons of their own. The great temperatures and pressures created by fission explosion are also used to initiate fusion and thus detonate a thermonuclear bomb.